Matter. Anything that has mass and occupies space is called matter. But I wonder, everything that is matter is made up of what? Well, matter is made up of very small particles. How small are these particles? Well, they are so small that they cannot be seen with naked eyes. Let's take one example. Suppose we have 6 beakers of water. Now what we do is we are going to dissolve potassium permanganate crystal in the first beaker, which is a little pink in color. Once we dissolve the crystal, we will see that the entire solution now has become pink. This indicates that potassium permanganate crystal has divided itself into several particles, small particles, due to which we can see a color. Now let's take 10 ml of this solution and let's put it in the second beaker of water. Do you see some color there too? Yes, the color has become a little lighter, but still we can see some color. This indicates that the particles have divided themselves more and imparted color in the entire water. Now let's take 10 ml of the second beaker and put it in the third beaker. We again see that there is some color seen in the third beaker, though it is lighter, but still the color is visible. Again, this indicates that the particles have divided themselves more. And if we continue doing this, we still see that in the sixth beaker there is still some color shown. That is because the particles have still divided themselves. That means the particles are so small, they keep on dividing themselves and become very small. This indicates that one small crystal of potassium permanganate is made up of millions and millions of tiny particles. So this tells us how small the particles of matter can be. Okay, now let us study about these small tiny particles in detail. Now suppose I have a beaker of water and I check its level in the beaker. Okay, now let's take sugar and dissolve it in the water. Okay, still I can see that the level of the water is same, it has not increased. Then where is the sugar gone? Has it not occupied some space inside? Well, it should occupy some space because sugar is matter. Then why did the level of the water increase? That is because the water particles have some space between them, and the sugar that we put inside the water occupies itself in these spaces available. So we can see one thing, that particles of matter have space between them. Well, in the solid state, the particles of matter are closely packed, so they do not have much space between them. The space between these particles is negligible. In the liquid state, these particles have space between them, but moderate space. Whereas in the gaseous state, the particles are far away from each other and they have a lot of space between them. Look at the glass of water. Is the water inside constantly moving? Yes, it is. Does this indicate that the particles of water are in constant motion? Yes, it does. Well, matter is made up of those small particles which are in constant motion. In solid state, in liquid state or in gaseous state, all the particles are in constant motion. Anything which is solid is made up of tiny particles which cannot move because they are so close to each other, but they vibrate in their own place. In the liquid state, the particles are in constant motion because they have some space between them. They collide with each other and move. And in the gaseous state, the particles move at a greater rate because they have a lot of space between them. So everything that is matter is made up of particles which are in constant motion. Let us study about a concept called Brownian motion, through which we understood that yes, the liquid particles are constantly moving. There was a scientist, Robert Brown. Robert Brown one day thought of doing one experiment. He took a glass of water and he put some pollen grains inside the glass. He saw that the pollen grains are continuously moving in a random manner. Does the pollen grain have some legs to move? No. then what is the thing that is causing their movement? The particles of water are in constant motion. That is the reason why they hit the pollen grains here and there, and the pollen grains are seen to be moving in a zigzag manner. This was observed by Robert Brown, and this is what we call Brownian motion, the motion of the particles of pollen grains which is in a zigzag manner. This motion is called Brownian motion. So we define Brownian motion as the zigzag movement of small particles suspended in a liquid or a gas is called Brownian motion. So here, because of the liquid particles, we can see that the pollen grains are moving zigzag. So Brownian motion is of the pollen grains due to the water particles. Now let's check if some particles are suspended in gas. Does the gas particles hit them? Are they moving? Well, we can see this in a dark room. If you have a small hole and sunlight is coming inside, you can see some dust particles moving here and there. These dust particles are showing a zigzag manner movement. That is because of the air particles that are constantly hitting them. This indicates that the air particles are in constant motion. Okay. So zigzag movement here is of dust particles. Dust particles are showing Brownian motion because of air particles. So the definition is justified now, that the zigzag movement of small particles, in the case of pollen grains zigzag movement, and in the case of dust particles zigzag movement, suspended in a liquid or in a gas. Well, there is one more concept due to which we can understand, yes, the particles of matter are in constant motion, and that is diffusion. Now suppose if I take a beaker of water and I put some ink inside. The ink mixes with the water uniformly on its own. Do you do something for the ink to mix? Do you push the ink? No. That means I can say that this is happening on its own. This is what we call diffusion. Diffusion is nothing but intermixing of particles of matter amongst each other on their own. Thus, diffusion tells us that particles of matter are in constant motion because they are moving and intermixing with each other on their own. Well, diffusion is very easy to be seen between two gases because gaseous particles are constantly moving at a greater rate and they have space between them, so they can diffuse very easily. Diffusion can also be seen between liquids. When two liquids are mixed with each other, they intermix on their own very easily because the particles of liquid have space between them and they are constantly moving too. But whereas when we talk about solids, solid cannot diffuse into each other because the particles of solid have negligible space between them and they are vibrating at their own places. Now let us study about the particles of matter a little more. Now let's take a chalk and let's take an iron nail. Both of them are matter. Both of them are made up of particles. Let's try to break them with a hammer. Which one is easier to break? The chalk. Why is the chalk very easy to break and why not the iron nail? Both are made up of particles. But there is a force of attraction between the particles of chalk as well as the iron nail. But in case of chalk, this force of attraction is little less. It is weak, due to which it is easier to break the chalk. Matter is made up of particles which attract each other. The force of attraction in some cases is very strong, whereas in some cases it's weak. Okay, whatever we have studied till now about the particles of matter are the characteristics of these particles. The first characteristic is matter is made up of very tiny particles. The particles of matter are very tiny. The second characteristic is the particles of matter have space between them. The third one says the particles of matter are in constant motion. We come to know about this using two concepts, that is diffusion and Brownian motion. And the fourth one says particles of matter attract each other.